Alright, now let's cover some acid-base theories. There's actually at least 3 acid-base theories. We're only going to expect you to know these 2. This big word up here in the top left is pronounced Arrhenius, and then you have the Bronsted-Lowry theory. They basically say the same thing, but using different words, different terms. But in the Arrhenius theory, we say that acids ionize. I'll show you what ionize means in just a bit, to form hydrogen ions. And then we say bases dissociate to form OH ions. Now generally this H plus ion up here comes in the form of H3O, and the name for H3O is hydronium. It's something you need to know, because you're going to see it written as both H plus and H3O plus, so make sure you know that those really mean the same thing. So we're going to stick with the Arrhenius side for now. And so remember, acids ionize to form H plus ions. The way this looks is if we start with HCl, this is an ionization by the way, we're going to mix that with water, and we're going to form the anion of the acid. So this chlorine here is going to become the ion, and then plus this hydrogen is going to react with H2O to form that hydronium right there. And that's all it really is. Remember, bases dissociate, and this is a little bit different of a reaction. But let's take a sodium hydroxide, and this time we don't really say we react it with water. We say it reacts along with water, H2O, and it separates just like those electrolytes did the last unit. It's going to go into one sodium ion with a +1 charge, plus an OH ion with a negative charge. So it works the exact same way. But make sure you know the difference between ionization and dissociation. Ionization has water as a reactant, dissociation has water on the line. Ionization forms hydronium, dissociation just forms 2 different ions just separating apart. So the Bronsted-Lowry theory, switch over to the right side, we say that acids equal proton donors. Remember, by protons we mean hydrogen ions. And bases are going to be proton acceptors. I think this is a little bit easier of a definition. So acids donate, bases accept. I'm just going to do one big example for you guys because it makes more sense when you see it all together. We take our HCl from the last acid plus an NaOH, just like the base we used in the last example. What's going to form is an H2O and an NaCl. So what happened is, I'll do this in green, the acid, HCl, hydrochloric acid, donated its hydrogen to sodium hydroxide, which dissociated into OH. So those 2 joined and made water, which left the sodium to bond to the chlorine to make our salt. So our acid donated, our base accepted it, we always form water. Okay? OH plus H equals H2O. Here we go. Amphoteric. This is a vocabulary word you need to know. Amphoteric, this is kind of long, is a substance that acts as both an acid and a base. So it can go either way. It can donate a proton, it can accept a proton. It can ionize or it can dissociate. Both of those terms go along with this amphoteric species, and the only one you really need to know is that water, H2O. Remember, it can form H3O and accept a proton, or it can go to OH and donate a proton. Either way it wants to go, it's fine. So here we go again. Acids ionize to form H plus ions or hydronium ions, same thing. So go over to the right side, let's practice. Write the ionization for nitric acid. So write HNO3. Ionization, you do H2O as a reactant. You have to form the hydronium, the H3O, and then the anion for the acid, which is going to be the NO3 with its negative charge. Do not forget your charges. So now let's do H2SO4. We're ionizing, so we're going to add that water as a reactant. We know we're going to form our hydronium product, and then we're going to keep our sulfate anion. Now this isn't balanced. I'm not really concerned with balancing it. As long as we get this far, I'm happy. So then bases will dissociate in water to form hydroxide ions. So let's write the dissociation for KOH. Just KOH with a water line to form 1 potassium with a +1 charge and 1 hydroxide with a negative charge. Now the reaction for CaOH2 is CaOH2 with a water arrow. We have 1 calcium with a +2 charge plus 2 hydroxides with its minus charge. Remember that 2 came from the subscript right there. Sorry, I should have put parentheses around that. My fault. And that's all we're going to get into this video.